Hi there everyone, how are you? And today we are going to talk about the magic triangles of physics. This is a way that you can learn or review the basic ideas of physics and start to put them together in your head. Physics is not easy to get comfortable with, and this video will be better if you have learned a little already, but I hope that either way it will help you see what physics is all about. Physics uses a lot of maths, and the simplest equations in physics look like this. A equals B multiplied by C. And A, B and C are physical qualities from the real world. This is called a linear proportional relationship in maths. Now, don't get scared off by the name, we'll go through it backwards. A relationship means that A, B and C are linked to each other, they are connected. Proportional means that when you change one value, one other value has to change with it. And linear means that when we change two values like this, they make a straight line. For example, let's say B is always the same. We keep B constant. When we put C up or down by 1, A will go up or down by B. If B equals 2, then when C goes up by 1, A goes up by 2. But if B equals 5, then when C goes up by 1, A will go up by 5. We can also use maths to rearrange this equation. If A equals B times C, we can divide both sides by B, like this, or we can divide both sides by C, like this. Either way, we can then cancel because B divided by B equals 1 and C divided by C equals 1. We now have two new equations. C equals A over B and B equals A over C. Now that we have these equations, we can put the values into a triangle. Here we can see A at the top is B multiplied by C at the bottom, and B on the left is A divided by C on the right. This helps you to remember the relationship. The letter at the top is calculated by multiplying and the bottom by dividing. You just need to remember what the letters mean and which letter is on top. It's a common mistake to think that there is a rock, paper, scissors type relationship. But you must remember that whatever is A will always be on top when you are dividing. There are a lot of equations like this in physics, and we're going to go through some of them now. You probably won't need to know all of these at one time, but you can start to see the math that runs all the way through physics and see that it works the same way in something like mechanics as it does in something like electromagnetism. Of course, physics equations will get much more complicated and hard to remember, but the maths principles always work in the same way. And whatever area of physics you are studying right now, remember that practice makes perfect. We're not going to do any practical examples in this video, but you must do practical examples to get better at physics. So our first triangle is F equals ma. This is sometimes called Newton's second law, and it's about how hard things hit. F in this equation is force measured in newtons. M is mass measured in kilograms, and A is acceleration measured in meters per second squared. Acceleration is not speed. You can think of it as the feeling of being pushed back in your chair if you are in a car that starts very quickly from a green light. One quick side note is something that you need to get right is units. Numbers don't mean anything unless they are connected to something in the real world. The units in these equations are connected in the same way as the numbers, even if we sometimes use different names. For example, another way to describe the Newton is the kilogram meter per second squared, which we can see in the equation. 1 Newton of force is the mass in kilograms multiplied by the acceleration in meters per second squared. We can also see here the unity 1 equals 1. It might sound like a silly thing to say, 1 equals 1, but saying that this thing is exactly the same as that thing is a very important thing to be able to do in physics. Our next triangle is the speed equation. This tells us how fast something is moving through space. In this equation, d is distance measured in meters, how far you go. V is the speed or velocity measured in meters per second, how fast you are going. And t is time measured in seconds. Speed and velocity are nearly the same thing, but not quite. The important thing is velocity has a direction. Our next triangle is acceleration. This is that feeling of being pushed back in your chair I talked about before. It is how quickly something is changing speed. In this equation, v is velocity again, but we have that triangle which is the Greek letter delta to signify a change. This is something we do a lot in physics. The change in speed is like speed because it is measured in meters per second. A is acceleration measured in meters per second squared. And t, or delta t, is the change in time, which is again measured in seconds. Our next triangle is about momentum, which is about the amount of movement, which is already quite a difficult idea to think about. In this equation, p is momentum measured in kilogram meters per second. We use p so it is not confused with m, which is mass in kilograms, and then v is again the speed or velocity measured in meters per second. Our second side note is to ask, why is physics so hard? This is not an easy question, and everyone has different problems. But one reason it's hard is because the different letters talk about subtly different things. Mechanics is easier to explain. I can talk about the difference between moving fast and feeling pushed back in your chair as your car or vehicle starts to move. That's the difference between speed and acceleration. But as we go further and further, these differences get harder and harder to understand. An example is momentum and force. Look at these two pictures. In this picture of pool balls, the momentum will decide where all the balls will go and how fast they will be moving. In this picture, the momentum of the three blue players will decide where the player in black will hit the ground. But that's not what any of the players are thinking about at that moment. They are feeling the force of the impact. It's easy to make this difference when we use objects for momentum and people for force. But you have to remember that there is both force and momentum in both of these pictures. Our next triangle goes even further in making things hard to understand by putting an amount on work. It is the amount of mechanical work that comes out of a force. Work is measured in Newton meters, force is again measured in newtons, and d is the distance measured in meters. And at this point I will quickly mention that the case of the letters is important. We have big W, big F and small d. Work done is also a measure of energy, which again is making things even more abstract. Here we can see another way to think about work. In this equation, work is power multiplied by time. Work this time is measured in joules, which is the unit of energy. Power is measured in watts, and time again is measured in seconds. Another unit we can use is that 1 watt is equal to 1 joule per second, and the joule is the amount of energy. What is energy? Well, actually, scientists don't have a really good answer for that right now, but we do know it is everything that makes the world. Our last three triangles are going to go into electromagnetism, and even more than before, if you haven't studied any electromagnetism, you will need to fully understand this part of the video. Again, everything is becoming even more abstract and hard to understand. But in this equation, we're talking about how much electricity is moving. It's a little bit like the speed triangle. Q is charge, measured in coulombs, and charge is an amount of electricity. I is current, measured in amperes, and it's a bit like the amount of electricity flowing. It can be compared to the current of a river. T, once again, is time measured in seconds, and 1 ampere is 1 coulomb per second, kind of like speed is measured in meters per second. In this equation, we put an amount of energy on electricity. E is electrical energy, and it is measured in joules, just like we saw before with work. V is a voltage, measured in volts, and Q, again, is charge, measured in coulombs. So voltage is connecting how much charge we have to an amount of energy. There are other different types of energy, and they are all measured in joules. And once again, this is where 1 equals 1 becomes important. We are able to say that these things are the same thing, but we don't quite know why. Finally, we have this triangle, which is one of the first you will learn in any course on electricity. It talks about the amount of electricity in an object. That's not a great way of saying it, but we have voltage measured in volts, the current, the speed of electricity flowing through an object, measured in amperes, with the resistance of the object. And this is where what the object is made of becomes important. Metal has a much lower resistance than wood, for example. That is where we can stop for today. I hope I have given you some idea about how to use these triangles, but I have not done any practical examples. So whichever part of physics you are studying, it is important to work through some problems using numbers to make sure that you know how to use these triangles. If you would like a more practical video on any of these topics, then let me know in a comment below. Like I said, maths continues to work for all of these equations and others in physics, and we can see that maths really is ridiculously good at making pictures of what is happening in the world. Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. Mathematics and physics is the reason why you can watch me on this video in your house, maybe with electricity and a car in your drive and a GPS to tell you where you are, and all of the other things that we have in the modern world. And this effectiveness of math is sometimes shown like the difference between a black and white checkerboard and the blurred image that you see on the right. Mathematical truth shows these bright lines, but the real world is different. It is messier, and there are still things that we don't understand. But in physics and the other sciences, maths is taking us closer and closer to what is really happening in the world. There is then the very different question of how we feel about that, but that is not a topic for this video. Thank you very much for watching this video. Please let me know what you think below. I know that the subject is a little bit strange, but I hope that it has been useful for people to understand physics a little better. If it has, please like the video and maybe subscribe to our channel. You could even pass it on to a friend who you think might enjoy it. Bye for now.